I'm an associate director at Arup, and I'm quite fortunate because I've worked on numerous existing buildings, and this is something that I'm very passionate about. And as you've heard today, a number of the speakers have been talking about existing buildings, and many of you will also have noticed that adapting and reusing existing buildings is now becoming more and more common, and it's very much in the limelight. So I'm going to use some examples of projects that I've worked on whilst at Arup to help illustrate some of the considerations that you may need to have to reuse existing buildings, and hopefully kind of open your eyes or kind of give you the confidence to sort of have those discussions with architects and your clients. So construction declares, this is something that Will touched on right at the very start. The built environment is obviously a major contributor towards climate change, but we as structural engineers, we can actually play an important role in tackling this problem. So construction declares, this is a global petition that many of you will have seen, and it's for the construction industry and the built environment, and it declares that there is a climate and biodiversity emergency crisis. And a number of firms and organisations, they have pledged their support for this. And what this declaration states is that we have to take positive steps today. And a big part of those sort of positive steps include upgrading existing buildings as a much more carbon efficient alternative to demolition and new build. And this was also highlighted earlier by Natasha and Margaret. So many people, not just engineers, this is architects and clients, working on predominantly on new buildings, they believe that reusing existing buildings is a compromise. But we can really challenge that perception. And there are countless examples where existing buildings have been transformed into some of the most exciting and dynamic places in the built environment. We heard earlier that transforming existing buildings, it can cut embodied carbon by up to 70% compared with demolition and reconstructing. And there are so many other benefits. So, for example, transforming existing buildings, they can also bring social benefits. And this is a really good example at Coal Drops Yard in London, where largely derelict heritage buildings that you can see here, they've been radically transformed. The client's vision here was to restore these Victorian warehouses. They were listed, so we needed to preserve their historic character, but also create a dynamic new public space. So it wasn't just about reusing the buildings, but to create something quite new and different. And a considerable amount of work was required here by the structural engineer. So this involved assessing the existing buildings, and they've now been restored. But also that transformation, it introduced this new roof structure that peels away from the existing, and a new retail space has been hung from this roof to kind of create this floating space over a public plaza. And this hopefully illustrates that you know, in this case, Coal Drops Yard, it's now the centrepiece of the regeneration of the wider King's Cross area. And the transformation of these existing buildings, it's now created this vibrant area with restaurants, bars, cafes, public spaces, and people actually go to visit this area. So, you know, it's a real placemaking achievement. So, as engineers, as I said before, we have a vital role to play in influencing our clients and the architects that we work with to reuse and transform existing buildings. And often the decision to retain an existing structure, this requires some input from the engineer. It can be easy to simply focus on the risks and the problems associated with keeping it, rather than the potential rewards. And, you know, it may seem difficult, but it's important that we're able to address these considerations. Reusing an existing building isn't always the answer, but it's important that we do carry out an informed early assessment, and this can potentially reveal the exciting opportunities that existing buildings can bring. So, what does the client actually want? It's great to hear Margaret talking about, you know, the discussions that you can have with the client, and, you know, this is where we have that key role. If your client wants to know what to do with their existing building, the first step is to understand exactly what they want. What are their drivers? Are they unhappy with the existing building? If aspects are inadequate, can it be adapted rather than immediately conclude to rebuild? Are there structural problems and can they be repaired? And does the building layout work? So this is a big one actually that I find. For example, common challenges include inadequate circulation, insufficient natural light, or limited floor to ceiling heights. But these issues, they can all be addressed through a multitude of interventions, and it's really important to drill down into the detail because we can help inform a solution that doesn't involve demolition. And as I said, it may not be straightforward, but it's really, really important that we can articulate and explain those potential options and solutions at that early stage. So in addition to understanding your client's issues, it's also important to discuss the bigger picture with them. Sometimes the focus can be just on short-term goals for that specific project. And Coal Drops Yard is a really good example where the client may own several buildings in an area, and reusing an existing building could unlock future potential for the surrounding area. And that's exactly what happened around the King's Cross area in London. And there are many other examples where the history of a building is celebrated just by retaining it, and it can actually add value to a client's portfolio. So where do we start? A structural desk study is vital right at the very start to develop a better understanding of the existing building. For example, the date, this may indicate potential inherent defects. Knowing who the architect or engineer was, this can inform the detailing, the materials or structural systems used on that building. And also it's important to have a timeline to help understand any load path modifications that may have taken place. Retrieving the existing information, this includes building records, calculations, but also other things like historical papers, articles, and photos. These can be just as useful. So the desk study, this helps to develop a clear understanding of the existing structure, and this can also inform how it could be transformed and reused. But it's also essential to identify and document the structural arrangement, the existing structure, and the elements. And this can involve inspections, local opening up, but also revisiting that desk study. And it's a real iterative process just to try and fully understand how the building works, how it was put together, and how it stands up. So following on from that, it's also important to understand the building's condition. Inspections, opening up, and survey works, these can help to develop a much better understanding. They can also confirm the accuracy of the desk study that you've already carried out, and validate your kind of structural systems, and also identify any defects. And with defects, it's important to not just straight away condemn the building, but understand why did they occur, and ensure that any remedial works are actually effective. So, the engineer here has to have the confidence that they understand how the structure works, there is an identifiable load path and stability system, and also that the building doesn't show any signs of structural distress. However, it's not necessary to always carry out extensive calculations with existing buildings, and sometimes the historical performance, it can actually justify its future performance. Here you can see the listed Arkwright building at Nottingham Trent University, which was built in the 1800s, and previously it had suffered significant historical movement down to settlement. But rather than condemning the existing structure or attempting excessive repair works, we carried out detailed investigations to understand why the building had moved and whether it was continuing to move. And here the design approach accepted that the building may move, but changes of loading, both temporary and permanent, were minimized. And where change was unavoidable, we just locally enhanced and strengthened, but we accepted that the building would continue to move and it needed to be monitored, but not doing something excessive or demolishing the building. So the listing is important. Is the building listed? Listed buildings are nationally important, and therefore they have extra legal protection. So the listing, it recognises that it's special, and it does bring with it controls over alteration, extension and demolition. And it can be perceived sometimes as a hindrance, but what's really, really important here is for the engineer and the designer to understand the philosophy of conservation. And this involves adopting principles such as minimum intervention, reversibility, and honesty. And conservation accredited engineers, they can understand these considerations and apply them to existing listed buildings. So we have a pivotal role to protect and prolong the life of these sorts of historic structures, but it does require the engineer to develop a wider array of skills and knowledge. And it's worth, as I said, reading up about the conservation accredited engineer. So loading is an important consideration. Natasha talked earlier about the actual floor loading on an existing building. Often the codes would suggest a much higher load than is actually required. So when you are working on an existing building, just think about the loads that it will actually experience and what you need to design for. Change of use is something that I'm seeing more and more today. And change of use can give a building a new lease of life, particularly as keeping it occupied, it helps to guarantee its maintenance. It can result in load increase, possibly through new services or additional imposed loading. But unlike interventions, the implications of change of use can be quickly determined at a very early stage. So, for example, there's been a trend to convert offices to residential. And this can be relatively straightforward because there is a reduction in loading. Another important thing is trying to compare the existing superimposed dead and imposed loads against the likely applied dead and imposed loads. The comparison that you can see here on the right-hand side, this really helped to avoid major strengthening works, and we're able to repurpose an existing building. So floor to ceiling heights, this is another very important consideration, and it should be reviewed as early as you can, because this can also influence the reuse. So for example, offices, they typically require greater heights to accommodate services. And here you can see at 1 and 2 Stephen Street in London, this was a 1980s building which has been transformed into an efficient and stylish workplace. So here, an underground parking and loading bay, it's been converted into flexible offices, and the floor-to-ceiling heights have been maximised by adopting a sort of semi-exposed services design with bespoke floating rafts. And structurally, it's relatively straightforward, but it's having those early discussions and coordinating that design to maximise those floor-to-ceiling heights. And this transformation, it increased the lettable area by 10%. Which significantly increased the rental value, and it didn't require a new build. A much more radical approach here was taken at the George Green Library at the University of Nottingham. Here the building was to be reused. It was a 1960s building, but the basement, it wouldn't meet modern building regs for headroom, daylight and access. And here the columns have been lowered, so we've transformed the basement into a more usable ground floor. It did require some major temporary works to support the existing structure. So you can see there on the right, there's a pair of steel channels that were clamped onto the existing columns, and using hydraulic jacks, we gradually transferred all of the load from the building onto the temporary frame. And this process was repeated, and it allowed each of the existing columns to be lengthened, and we created a much more usable level under the building. So the internal layout should also be reviewed just to ensure that it meets the client's requirements. It can be easy to dismiss the future use of a building on the basis that the existing structure is a constraint, but there are many options available for the structural engineer to transform spaces and innovatively and also cost effectively. This is a really radical transformation of the Museum of Contemporary Art Africa in Cape Town. And it was a grain silo which was previously used to store maize, and it consisted of 42 concrete cylinders that you can see on the top left. But it was disused due to containerized shipping. And rather than demolishing the building, spaces have been carved out of the cellular concrete structure to form 5 floors of galleries and an atrium. And this allows natural daylight into the space, and it's revealed the original intersecting geometries in quite an unexpected way. And here the structural engineering, it's given a historic silo a completely new lease of life by reimagining the interior space, but still maintaining the industrial character. Although the existing structure can be reused, new services often need to be inserted, but the building shouldn't be treated as a blank canvas and for the services distribution, but a starting point should always be to try and coordinate and thread through the original fabric. So this does require a bit more investigation and close coordination with the building services team, but you can generate quite significant cost and program savings. So here's an example from a 1960s building, and it had a previous life as a chemistry department. After we opened up, we found that there were drainage channels in the lab floors and penetrations through the existing beams, and these were then used to distribute all of the services, which maximise the floor-to-ceiling heights. You've heard earlier about reusing foundations, and this is becoming an important consideration, particularly in inner city sites. So this can be due to congestion in the ground from generations of development, and therefore installing new foundations can be quite difficult and also costly. But reusing foundations can yield significant cost savings and also increase program certainty due to the reduced risk. So we need to try to understand the capacity of existing foundations, as you heard earlier, and even if there is an increase in load, it may still be possible to reuse them. Here you can see One Triton Square in London, which was designed in the 90s, and we were asked to update the building for the latest work styles, and it involved introducing 3 extra floors, but we were able to retain the existing superstructure and substructure.
Many old buildings have poor environmental performance, often suffering from summer overheating and significant heat loss in the winter. So the envelope is an important consideration. The existing cladding, this can be removed entirely, stripping back to the existing structure and replacing it with a new system. However, the weight of the new cladding, this needs to be considered to either match the weight of the original, or it's important to determine the extent of strengthening that's required. Here you can see the development of the Arup office in London, which involves stripping 2 existing 1950s buildings back to the bare superstructure, and it had a new cladding wrap to create a single office. An innovative approach was adopted here, which incorporated all of the ventilation distribution within the facade, and this helped to maximise the floor-to-ceiling height. Phasing can be an important consideration to understand how the works can be carried out. For example, can the building remain occupied with phased construction? Here you can see the George Green Library at the University of Nottingham, and this was a design competition where one of the client's drivers was to keep the existing facility operational whilst providing a state-of-the-art building. The phasing and decant strategy we developed here on the left-hand side avoided needing temporary accommodation and kept the facility open throughout. Temporary work should also be considered. The Newton Tower at Nottingham Trent University was a building with lots of cellular spaces and dark corridors. So the proposal here was to open up the lower levels and remove the solid walls at the base, which was supporting 9 stories of stone facade and also stabilising the tower. Here you can see some of my sketches which show how we thought about how the construction could be planned so that the stone could be supported, the tower stabilised, and new steel goalpost frames installed, which would help to open up the space. And here you can see the construction photos. So on the left-hand side, you can see the temporary frame being installed. In the middle, you can see the new steel goalpost frame installed beneath that stone and stabilising the building. And then on the right-hand side, you can see how the lower levels have been completely opened up and the space transformed. So imagination is needed at the early feasibility stages to be able to identify the potential within an existing building. And there are so many missed opportunities. So transforming and reusing existing buildings, this can offer many advantages over new build, including being more cost effective for clients, and also it can create characterful places and help to preserve the heritage value for future communities. And as structural engineers, we should be aware of these benefits and be able to confidently discuss them with our clients, as it may be possible to justify the case for reuse over new build.
Thank you, Steve. Thank you. And sorry to cut you off there at the end. I mean, absolute wealth of knowledge. And just for people listening, please look out in a couple of, I guess in about a month or so's time. Steve's written a really fantastic paper on this topic that we're publishing in the Structural Engineer around many of the ideas that he's just explained and the sort of starting points towards reusing buildings. A really good question for Steve, which actually this was asked earlier in the day when we were talking about lean design, and I wanted to wait until we got on to reuse because it's the big overlap between shall I design lean and efficient now, or do I try and put in additional capacity? So I just wondered if Steve, you could for a minute reflect on, have you come across buildings that you've tried to reuse and ever been unable to reuse them because they were sort of designed too bare in the first place? Is that a risk that we're putting out? Will designing lean today prevent us from reuse in the future? What are your thoughts on that?
Yep. So I think there's two scenarios. What I found with existing buildings is that there often is some spare capacity, and I think we heard about this earlier about, say for example, plant loading, and I've had this before where we couldn't reuse the existing building, introducing 7.5 kPa, a blanket load of 7.5. But what we did is we worked really hard to determine exact weights of units. And it was a lot harder on the structural engineer because we had to look in a lot of detail, and it was an iterative process to relocate units and redesign the M&E systems. But we were then able to incorporate this new loading without strengthening. But then we did also hear earlier today that there are opportunities using things like carbon fiber strengthening and maybe local strengthening, and that's the key thing, is that you may end up having to do some local works, but you're not applying it blanketly across the entire building. And I think in terms of lean design, for the new buildings that we design, it's just thinking quite carefully about what could happen in the future. How can we efficiently design the structure so it can be adapted? So a simple example is I was working on some multi-story car parks, and we did think exactly about, will the use of cars change? Could the building then be repurposed? And we were talking about potentially introducing retail spaces at the lower levels, which just meant a slightly taller level at the lower level, but not increasing the height of the building at every single level, and just thinking about what the use could be or what you could adapt in the future.
Yeah, fantastic. Thank you. So I think the key message is, of course, clever engineers will work it out in some ways. And my response is always that I think we're going to be even better at reusing buildings in 50 years' time than we are now. So I wouldn't worry too much, and we can plan ahead a little bit. That doesn't mean having to over-design things.